So I found one of these again the other day. There's been a lot of talk in the UK this week about banning the products that I get these out of, but that's another channel's discussion. But I think these batteries are great. And as you know, I've got a way to charge them. I use these little plugs on them. I've got this little charging board, so it goes in like that. I've just charged this one up. But there is a glaring problem with them. Well, it's not a problem. It's just part of their design. An issue with them is that they only give out, this should be charged, but really they only give out about 3 volts. Well, the nominal voltage is 3.7 volts, that's the target voltage. And with these little boards, you can charge them up to 4.2 volts and take them down to about, I don't know, 2.8, something like that. Anything lower and they can have problems and it can ruin the battery or your life. But these little boards, you charge them with USB, and USB is 5 volts. Well, standard USB, if you're not using any of the new USB standards. So this gives 5 volts. So you're putting 5 volts in and getting 4 volts back on this. And so many other things are 5 volts. See, and the other ways I've used this, I mean, you remember this that I made, which basically uses 3 sets of these in parallel, which give me about 12 volts. And that's more useful because I can run that 12 volts into something that makes it down into 5 volts and charge it with USB. It's the same as this scary beast as well. You know, that gives out 12 volts, does what it says on the printed circuit board. I feel that to get more use out of these, it would be great to generate 5 volts with them. Now, if you think about it, you get the little cheap power banks. I've not got one around from Poundland. They've got one 18650 battery in it, and that's a 3.7 volt battery. So there must be a little thing like this that will take it from this up to 5 volts for USB. So I went and looked for something. I mean, I could have just bought a power bank, of course, but I've got this little thing. Just have to clean the edges because I hate the rough edges on these where they have, well, they've just snapped the board when they've produced it and not routed the edges right. I don't know whether you can get fiberglass in your fingers from them, but once I thought that, I couldn't think of anything else. Right, so if you look at this, so look at the top bit of the board, it's really similar to that. Look, I mean, it's exactly the same, really. So it's got this power chip on it, and that's what charges the battery and controls it. But this little board's got an extra bit, which should, I think, give us 5 volts out. I'm going to try this. So let's get one of these little plugs and we'll see what happens. So got battery positive and battery negative there, so it's easy for me to solder that on. So let's do that to begin with. So the bottom one's negative, so the bottom one's black. Let's just, should solder quite easily, hopefully. I'll be all right as long as I don't put it on a big metal thing that takes the heat away. All right, and so bottom one's black. I think I'll turn these, make those a little bit smaller. And then the positive goes to that one. All right, lovely. So if I, better take it off this metal thing now. I think if I plug that into here, shouldn't really see much happening. So as long as this has held its charge, this should now be giving power out. So let's see whether I can actually get a voltage out of this. If this doesn't work, I'm going to have to go and change to a different multimeter. So there's negative, there's positive. Oh, right, okay, 4.2. So I'm getting 4.2, which is what I said it should be. All right, now I should have a voltage out. So I think that voltage out there, I think these two are voltage out. So let's try that. Yeah, so 5.6 out, which is USB voltage out. So we're getting 4.2 volts from there, and this is giving 5 volts out. So that's really cool. I mean, this is a bit of a big board, unfortunately. I think it would be nice if we could somehow split this board in two and have one on the bottom and one on the top, and then it would be a smaller footprint. It means that I might be able to put this in sort of in a little gadget somehow. So if there's something that I just want to, I don't know, run something that's USB, if I've got a small thing that's USB, I could then plug it into this, have it battery powered. So I feel like I ought to put a USB plug on this and see how long I can power something out of one of these. Right, let's see if I can find a little socket breakout board, and then I can solder it across. And I think I'll cut these wires smaller so that I've not got this massive wire coming out of it. Okay, I've got this little plug, and I've just been trying to work out which of the connections are red and black, and I've taken a live USB socket and I've probed it to work out which is the red one and which is the black one. It's the two end ones, as I thought, so I assume they're those end ones there. I better just put the beeper on it just to make sure. So that one there, I hope, will be that pin there. Yeah, that makes sense, and therefore that pin should be that pin, just about. Yeah, right, so that pin there, the red pin is that side and the black pin is the other side. All right, so let's solder that on. I'm a little bit bothered about this plug because it's got these resistors on, so I'm not sure what they do. They probably tell the USB that it can do certain things, so I have to see how that goes. Because really I don't want this to be a smart thing, I just want it to send 5 volts out, and that's all. So there's my little gadget. The first thing that I need to do is plug this in and see whether the smoke comes out. So I better make this, well, let's hold that there. Then if the smoke does come out, you'll see and enjoy. All right, well, nothing immediately. And then it's just a case of finding something that's USB that will fit in that. So I've got a little USB light here, which should work on 5 volts. Just check that that's not hot for any reason. No. And let's see whether these are from IKEA. Let's see whether it works. Hey, it does. All right, I mean, this is an LED itself, but there's probably resistors in here that consume the 5 volts because this is a standard USB thing. So I think the most interesting thing that I can do now is maybe plug this light into here, and I'm going to use one of these things. So let's see whether this gives a reading. You see that? So 5.52 volts, and it's not taking anything. So if I now plug the light in, so that's using 0.02 of an amp. So this will now count and see how long this battery lasts. So I'm going to come back later and see what it says here, and see when it turns off, see whether it tells me how much milliamp hours it takes out of this and how long in time it stays on. I'm not going to time lapse this because it might take days, who knows, so I'll just leave it and I'll see you on the other side. Okay, it's the next morning, you can tell by my voice, and the LED's gone off, but so has this, which is a bit worrying. So let's hope it hasn't forgot its measurements. So I'll just plug this charger in. Oh, there's the lamps come on. I'll unplug the lamp. Look, it's been on for 6 hours and 4 minutes and has some very, very small milliamp hours on there. So we've used that cell to power this LED for about 6 hours. So we could use this as a mini power bank for charging little USB devices. So I hope you found that of interest. I wonder what we could do with it next. If you'd like to see in a future video, please subscribe, and if you enjoyed this, you know what to do. Bye.